a magnetic storm, we have very beautiful displays of aurora at high latitudes. But there are also hazards that are associated with those magnetic storms. A large magnetic storm can interfere with radio communication, with GPS systems. They can interfere with the operation and orientation of satellites. During a large magnetic storm, high-altitude pilots and astronauts can be subjected to enhanced levels of radiation. And during a large magnetic storm, there are occasional power blackouts. Large storms can be an operational challenge and a hazard for the operation of electric power grids.
Magnetic storms are they're a hard concept to get one's head around, but essentially we're looking at a tremendous burst of energy coming from the sun. We might not feel that ourselves, but our electrical infrastructure absolutely does.
Space weather starts with the sun. It's brought to the Earth by the solar wind from the sun, and the solar wind interacts with the Earth's magnetic field. Sometimes when the sun is disturbed, it can therefore cause the Earth's magnetic field to be disturbed. It's a period of time we call a magnetic storm. Geomagnetism is a very old science, and it traces its history back to the discovery of the compass, which was of course useful for navigating the world's oceans. It is really nothing more than a magnetized needle which can orient itself in response to the direction of the magnetic field. It's quite interesting. There are occasionally periods of time when the magnetic field of the Earth is time dependent. And that means that if you were to take out your compass and very carefully observe the direction that the needle was pointing, you would notice that it's not always pointing in the same direction. It's sometimes kind of vibrating around and moving. The National Space Weather Program organizes the work of the many federal agencies that are concerned with space weather. This work is important for our nation's economy and for our national security. Space weather is a variety of subjects which stretches from the sun to the Earth. Different federal agencies have different responsibilities for different parts of that the physical whole of space weather. NOAA, NASA have responsibility for monitoring the sun, and they are also responsible for space-based monitoring of space weather. It's interesting though, the USGS has a very unique role. We monitor space weather from the ground. In effect, we are monitoring and essentially exploring space without ever leaving the surface of the Earth. The USGS operates a network of magnetic observatories. They are distributed across the United States and including our territories in the Pacific and in Puerto Rico. We monitor the magnetic field at these stations, at these magnetic observatories in real time, measure the magnetic field every single second. Data are transmitted back to our headquarters in Golden, Colorado, where we disseminate the data to our customers, other federal agencies, private entities that are involved with the operation of technological systems that could be affected by space weather.
These ground-based observatories provide critical information in terms of being able to understand the impacts of a magnetic storm. Both in terms, ultimately it comes down to the fact that our observatories are on the ground, and that's where all of us are as well. So we need to understand what are the impacts on the Earth's surface.
I'd like to emphasize two new projects that the USGS has recently undertaken. One is to provide real-time data for the oil and gas drilling industry. These days when you drill for oil, you don't drill just straight down. You drill down and then you drill out horizontally. In order to do that accurately and to know where your drill bits are headed, you have to have some understanding of the orientation of the drill bit. In the instrument package that typically follows a drill bit during drill operations, there is a small sensor in there which measures the direction of the magnetic field of the Earth. But to know which direction you are actually going, you also have to compensate for the fact that during magnetic storms, the direction of the magnetic field can change. And so the USGS is involved with making simultaneous measurements of the Earth's magnetic field at the surface to monitor the direction of the magnetic field so that the directional drilling operations can be accomplished with accuracy. The other project that I wanted to mention is mapping geomagnetic hazards. This is a new project which we've recently taken on and which is important for the electric power grid industry. We want to help mitigate their operational challenges and hazards that are associated with magnetic storms. So we are involved with making maps of magnetic activity, which are derived from data acquired by the USGS from its ground-based observatories. We are also mapping the nature of the Earth's crust so that we can construct maps of geomagnetic hazards that are useful for the electric power grid industry. Space weather represents a hazard and a challenge for the operation of technological systems, and this means that space weather is always going to be important for our modern society.